In the last few videos, we've talked about finding different probabilities and using combinations and permutations. Now we're going to put all of this together and try to find what's called an expectation value for different events and different games. I'm going to break this up into three shorter sections. Let's begin with section A, or lesson A. So, firstly, what is an expectation value? Well, an expectation value is what you can expect to happen when you play a game. And let's just write something down here. The EV, or expectation value, of a game, this is equal to the sum of all events values. In other words, for each event that could occur within a game, what is the value of each of those events, and then add them all together, and that's going to be the expectation value of the entire game as a whole. So how do you find the value of an event then? Well, the value of an event is equal to the probability of that event occurring times the outcome minus the cost. That is to say, the outcome is what you would get. If you win something, what do you win? If you lose, well, I guess that would just be 0. And then minus, there's a cost to play. So we're going to find the value of each possible event within a game, and then add all of those values together to find the expectation value of that game as a whole. All right, example 1. You are playing a game at the casino. To play, you roll a fair, so all sides are equally likely to be rolled, 6-sided die. If you roll an even, you win $2. Otherwise, you lose. So lose just means you get nothing. It costs $1 to play. Find the expectation value of this game. So there are two possible things that could happen. You could roll an even, or you could roll an odd. So what I need to do is I need to find the value of rolling an even, and I need to find the value of rolling an odd. So the value of rolling an even would be the probability of rolling an even. Well, there are 3 evens out of 6, or you could say that 1/2 of the sides are even. And then times the outcome minus the cost. So what happens when I roll an even? If you roll an even, you win $2. So I get $2 minus it cost me $1 to play. If I roll an odd, the probability of rolling an odd is 3 out of 6. There are 3 odds out of 6 sides, times the outcome says you just lose. So I would get nothing, 0 minus $1 to play. Okay, so now let's bring out the calculator. This is 3 divided by 6 times 2 minus 1. So that's going to be the top one. That value is 0.5. Okay, what about odd? That'd be 3 over 6. And this time times 0 minus 1. That's negative 0.5. So the EV of this game is going to be these values added together. It's the sum of all the values, and these are all of the different things that could happen. So let's add this together. The EV of this game, well, 0.5 plus negative 0.5, that's just going to be 0. In other words, on average, I don't expect to win money or lose money over time. If I were to play this game one time, of course I would either win or lose. But if I were to play this 10 times, 100 times, 1,000 times or more, the average would be I'd break even. I wouldn't win much, I wouldn't lose much. So we say this game is fair. If it's exactly 0, the game is fair. If the expectation value were negative, the player would lose that amount on average per play. So if the EV ended up being negative 0.25, then I would say on average, you would lose 25 cents per play. Okay, and keep in mind that it's not each play, it's on average per play. So you may not have a specific event where you would lose 25 cents, but if you were to play 1,000 times, then the average for each of those times would be 25-cent loss. If the expectation value were positive, you would actually win that amount though. So if the expectation value were 0.75, then you could expect to win 75 cents on average per play. Let's take a look at another example. Example 2. You're playing a game at the casino. To play, you roll a fair 6-sided die again, so all sides are equally likely again. But the game's a little bit different this time. If you roll a 1 or a 6, you win $4. Otherwise, you lose. Okay, so it costs $1 to play. I want to find the expectation value of this game. So I ask myself, what are all of the possible things that could happen? Well, one of them is listed. If I roll a 1 or a 6, I win $4. So let's write that. The value of 1 or 6, this is going to be the probability of getting a 1 or a 6. So that'd be the probability of 1 or a 6. Actually, we can just do, this is 2 out of 6. There's 1, 1, there's 1, 6. So that's 2 of those sides would satisfy this event out of 6 sides. Times the outcome minus the cost. The outcome is I win $4. The cost is $1 to play. But what are the other things that could happen? Well, I could get a 2, a 3, a 4, or a 5. In that case, I would lose because it says otherwise you lose. So 4, 1, 2, 3, 4 of these sides out of 6, I lose. And when that happens, outcome minus cost, I get $0, but it costs me $1 to play. Now, these are all the events that could occur. So let's find the values of each of these events and add them together. So I've got 2 out of 6. And we're going to multiply that to 4 minus 1. $4 I'd win, minus $1 it cost me to play. The value of that is 1. Okay, what about this? This is 4 out of 6. So 4 out of 6 times 0 minus 1. The value of this is negative 2/3 or negative 0.6 repeating. And if I were to add these together, well, 1 plus negative 0.6 repeating, this is going to be the expectation value of this game is 0.3 repeating. Or in other words, on average, I can expect to win about 33 cents per play. So if this game were available somewhere that I was and I had, an unlimited number of tries to play this game, I would play this because according to this, the player has an advantage. The player has an edge over the casino. And we'll do one more. If you're playing a game with casino, okay, you're playing to play, you roll a fair 6-sided die. If you roll a 1, you win $5, otherwise you lose. Okay, so what are all the things that could happen here? I could roll a 1 and I win $5. It costs me $1 to play. So let's write that down. The value of getting a 1, this is the probability of getting a 1, so that'd be 1 out of 6, times outcome minus cost. I win $5 minus it cost me $1 to play. Okay, what are the other things that could happen? I could get, well, anything else. So I could get a 2, a 3, a 4, a 5, or a 6. So the value of 2, 3, 4, 5, or 6, this is 5 out of 6. And then the outcome would be 0, I don't get anything, minus there's still $1 cost to play. Okay, these are all the possible events, so let's find the values. This is 1 over 6 times 5 minus 1. So the value of getting a 1 is 0.6 repeating. And then the value of getting a 2, 3, 4, 5, or a 6. So 1, 2, 3, 4, 5 out of 6 is the probability. And when that happens, the outcome is 0 minus $1 to play. That is negative 0.83 repeating. Okay, let's add these together. The expectation value of this game, 0.6 repeating, okay, plus negative 0.83. So this is roughly negative 0.17. So on average, you can expect to lose about 17 cents when you play this game per play. Now, this is just the first part of this lesson. Be on the lookout for the second part in the next video.